Today we're going to be looking at different types of chemical bonding, or different types of bonding. So our first type that we'll look more closely at today is going to be ionic bonding. And ionic bonding is a bond between a metal and a nonmetal. The next type of bonding that we'll look at later next week is going to be covalent bonding. And this is where instead of shifting where electrons are, covalent, they're going to share electrons. So this is going to happen between nonmetals and nonmetals. And the last one, we don't get too far into it, is metallic bonding. And this is between two metals. When we look at bonding on the periodic table, we first have to know what the ions are. So which ones are going to gain electrons or lose electrons when talking about ionic bonding. So what we started to look at last week was metals versus nonmetals. So our metals on the periodic table, group 1 has 1 valence, 2 valence, 3 valence. With those, they want to achieve the octet rule. So in order to do that, it is easier to lose electrons. So our metals are going to lose electrons. So if hydrogen's group 1 is going to lose 1 electron, it would get a +1 charge. So same group 2 is going to lose 2, +2, and group 13 is going to have a +3 ion charge. For nonmetals, we have group 15, 16, and 17. So group 15 has 5 valence electrons. To get to that octet, it's going to want to gain electrons. So nonmetals are going to gain electrons. So if nitrogen, which has 5, gains 3, that will give it 8. So it'll have a -3 charge. Group 16, -2, and group 17 is going to have a -1 charge for the 1 electron it will gain. So what we're going to look at is how to make an ionic compound. So what we're going to start with is ionic compounds, again, are a metal and a nonmetal. And we'll get into the name of it towards the end of the presentation today with the "ide" at the end. So we're going to look at lithium and fluorine and getting them together to make an ionic compound. So lithium, to start, lithium has 1 valence electron and fluorine has 7 valence electrons. So to get these two together, we're first going to start with 2 separate atoms. We're going to start with our metal on the left for lithium and our nonmetal on the right. So they'll first start as 2 separate atoms. Then our lithium, with its 1 valence electron, is going to give it to fluorine. So lithium is going to give its valence electron to fluorine. And what this is going to do is it's going to change the charges. This is where the ions come into play. If lithium gets rid of that 1 valence electron, lithium is then going to become lithium +1 because it's getting rid of that 1 electron. Fluorine's going to gain that electron, so fluorine's going to gain a charge of -1. The final ionic compound, when they come together, will have the positive as the metal and negative charge for the nonmetal. And this represents lithium fluoride. as that electron is going over and being exchanged from the lithium to the fluorine. Here's another example we'll look at using the electron configuration notation that we learned last unit in Unit 2. So what we'll start with here, again, ionic bonds, the electron transfers, so that each element can have octet, meaning that they can have 8 valence electrons. And after forming ions, the opposite attracts. So the positive ion gets attracted to that negative ion. So sodium starts out, sodium is in group 1. It has 1 valence electron like lithium. Over in the electron configuration, we can see that 1 valence electron by seeing 3s1. That's telling us in its last energy level, it has 1 electron. For chlorine, chlorine also is in the same period as sodium. So it's going to also have energy level 3 as its farthest out energy level. And within that, it's going to have 2 plus 5. It's going to have 7 valence electrons. So what we're going to do with sodium and chlorine. Sodium is going to take its outermost electron that's by itself, and it's going to give it to chlorine. Chlorine had 7. If you add 1, now chlorine will have 8 in its third energy level. Sodium will lose an energy level, but will have 8 in its second energy level. So if we get rid of this one and move it down, our final electron configurations for sodium will be 1s2, 2s2, 2p6. This will give 8 valence in the second energy level. And then for chlorine, since we're moving that 3s1 down to the third energy level of chlorine, chlorines will be 1s2, 2s2, 2p6, 3s2, 3p6. So if you look at that third energy level, 3s2, 3p6, that also adds up to 8. 2 in the s orbital and 6 in the p. So that allows us to have the electrons transfer and form an octet. So everyone's happy here. And now, when they get together, our sodium has the +1 charge, our chlorine has the -1 charge. So now they will join together as those opposite bonds attract. That positive is going to be attracted to that negative charge to form an ion. We're going to do a quick review and look at some other ions. So a review of what a bond is. So a bond is a force that holds atoms together. So like we mentioned, when opposites attract, that positive and negative are forming a bond that's going to hold that sodium and chlorine or that lithium and fluorine together. Ionic bonds are going to transfer an electron from the metal to the nonmetal. So from the sodium to the chlorine. Covalent bonds, like we'll get into later, they're going to share electrons. So they're not going to transfer any from a metal to a nonmetal. There are 2 nonmetals that are going to share electrons. Some examples of metals and their charges. These are the ion charges. So sodium, potassium, copper, all of these are going to lose 1 valence electron. That's what's giving it that +1 charge. The opposite in the halogens, we have fluorine, chlorine, bromine, iodine. All of these will gain 1 electron. to get octet. The -2, they're going to gain 2 electrons. -3, they would gain 3 electrons. So if we were to make some different ionic compounds using this chart, we have magnesium, which has a +2 in group 2, and chlorine, which is just a -1. So if we have Mg+2 and Cl-, that's not going to cancel and be neutral yet. So what you'll see down here at the bottom as subscript is a 2. So magnesium is going to lose 2 electrons. Each of the chlorine is going to gain 1. So in order for this to be balanced, we're going to have 2 chlorines. That would give us 2 negative charges and 2 positive charges to make it neutral. So our final answer would then be MgCl2 to make it neutral. One more example we can look at is aluminum sulfide. So aluminum is in our group 13. So it's up here. It's going to lose 3 electrons. Sulfur is in our group 16. Sulfur is going to gain 2 electrons. So this one's a little bit different because it's not that ratio where it's like 1:2 to make it even. So aluminum has +3. Sulfur -2. So you need to think what's a number they might have in common. So if we have 3 and 2, so 3, if we put 1 extra sulfur, let's see, S-2, now we have -4 and +3. So that's not balanced yet. Let's add 1 more sulfur. So we have 1, 2, 3 sulfur with a -6 charge. I'm thinking, okay, -6 + 3, how do I get those to be equal to 0, to have a charge of 0 for the final compound? What I'm going to do now is add an aluminum +3. If I have 2 aluminum, that's going to give me a +6 charge for the metals. Then I have 3 sulfur with a -6. Those will cancel out and give us our final ionic compound. So the final ionic compound is going to be, let me erase this real fast just so you guys can see next to it. So the final ionic compound is going to be aluminum. It's going to have 2 aluminum, and it's going to have 3 sulfur. So these numbers at the bottom, the 3 represents the 3 sulfur down here, and the 2 for the aluminum represents 2 aluminum in that ionic bond.